Good evening, everyone. So now we are going to know about the design patterns that are used in our in our diagrams. So now what are the design patterns? So these are the reusable solutions to common design problems. Now, what are these problems? Actually, whenever we design a system, then are some issues that we occur while adding some functionalities. So there are some predefined templates or known as architectural templates that we can use. It is same as like when we design some PPT, then we have some predefined templates for doing a or a cultural type of PPT. So we have some templates on which we can draw them. So in the same way, in the architectural part of designing a software, we have some predefined templates that if we will use, then we will solve those problems and it will not cause any error. The third thing is it improves readability, scalability, and flexibility. Now, how it improves readability? So as we know that they are predefined solutions, so a person who is reading your program, he already knows that yeah, this solution is used here. So this is of this type. Second thing is scalability. So let's say that you design an algorithm using those design patterns, then it is obvious that they are designed in such a way such that tomorrow if you want to scale your application, then it shouldn't cause any problem. Third thing is flexibility. That is there are a range of solutions that you can use by design patterns, and it depends on you that how much flexible you wanted your program to be. Now, what are the common design patterns that we use? So the first is the composite pattern. Now, how the composite pattern works? So there is the main component of it is this interface, and this interface is connected to one of the class known as the leaf class, and other is the composite class. Okay, and the other design pattern that we use is the mediator pattern. Now, what is the mediator pattern? So as you can see that there are project, mentor assignment, mentor, and team, and they all are linked to the mentor mapping service. This mentor mapping service will act as a mediator between all these classes, and any communication between these classes or any type of dealing of data between these classes will be held by this mediator class, right? Now, let's go with the uses of our composite patterns. So the use is database connection manager. So let's say that we are designing a software which is used for database. So now in that, if we want to connect different data, then this could be useful. Second is creating different types of notifications like SMS, email, and push. So here, as you can see that there is a single component and then it is connected to leaf and composite. So composite component is actually a component which has lots of other details except the main details. And the leaf component is a component that has details but not so much. Okay, it is like you have a function known as show details, and now in composite you have function like show details and some calculation too. So now by using this pattern, what you will do that you will do the simplest part here, but whenever a complex thing arrive, then you will use this you will use this composite structure, and then due to this communication, that is component of interface, we can communicate between these two, and we can define some recursive problems. Fine. Now, the third use of it is documenting creation like PDF, Word, and Excel. So it is like you have a text document. Your text document is your leaf component, and then you have your PDF, you have your .xls file. So these are your composite component. Okay, so now whenever you are trying to change your PDF component to let's say XLS or XLS to PDF, then there is a constant communication between these two, and this is done by this interface. Okay, so now let's see our problem, that what problem we are incurring in our system. So in our system, we can see that we have a team, and then we have this team component and this student. So this team component is nothing but it is an interface between team and student, and this is implement and this student class and team class both are this team component is inheriting both these classes, and team contains team component. Now, this student is the leaf here, and this team is the composite class, and this team component is an interface that is acting between these two, student and team. Now, let's say that we didn't implement this composite pattern, then what are the problems that we will face? So the first common problem is that a team has to store student directly. So now tomorrow, if you want to support sub teams, then there is no option. Now let's say that if there is a direct relationship between the team and the student, now tomorrow I want to run the algorithm again, and I want to make a sub team out of that team. Then that team shouldn't be in a hierarchical nature. Okay, it will be stored in a separate file, and then we will have a difficulty in maintaining the connections between the two. Okay. Now both the teams, student and team, act as a component. Student is a team component, and team is also a team component, but a composite. So as you can see here, that now we have used a team component. So the student is also a team component, and team is also a team component. And now team is a composite component, and student is a leaf component. So now a they both are a common component. That's why there isn't we will not face any issue in storing these two. Okay. Uh, Now let's say we have a team A, and we run the Hungarian algorithm again on this team. Then we will have a team B and a team C. Now this team B and team C are a part of team A. So if we will implement our solution, then we will have this type of structure, that is team A will contain team B, and then team B will have a student one, then team A will have a student two, then team A will also have team C, and then three, four, five. Similarly, team B dash will have team C, and team C will have students. So this is in this way, our solution will maintain the hierarchical nature of our software. Now let's see the code that is used here. So we will see the different modules, not combined but differently. So we have this interface component. So interface, we have only void show details. Okay, then we have this class student, and this class student has different functions like so this is the common that we are using this dot student id. So this is in this way we are assigning those details that obviously we will assign. Then this function is very important, that it will show the details of a student. It will show the name of a student along with the skill that he has. Okay. Then there is a skill get score, so it will return the score of the student, that is how much skill score he has, that we will use in the Hungarian algorithm. Okay, then there is an option of total score. So it will return the total count. Okay, total count of the score of the student. Then we have this composite team. This is the composite class, and in this composite class, we are implementing a list of team component. Okay, so we are implementing the list of this interface. We are using the list of this interface, and in this list, we have this again team this dot team id equal to id. And now there is again a method known as show details. So now this method will show details of team, and this method that is in the class student will show the details of student. So there is a difference between these two methods. That is, in this method we will have the details of student, details of team, and this method we will have the details of student. Now in this method there is one different thing, that we have a recursive call of this for loop, which is calling this team component again and again, and it is calling am dot show details. Now why this is important and how it is implemented, we will see in the later part. Then we have this skill get score, so it is doing those practical calculations of making those aggregation and aggregated score that we will put in the Hungarian. And then again we have this score calculation and all, which is not very important. Okay. Now, in this part, if you will see, then we are implementing this in our main function. So we have different objects of student ranging from 1 to 7. And then there is team B, also an object of team B, which is adding student S1. So, okay, we have this student S1 in team B. Then team C will have members like 3, 4, 5. So team C has 3, 4, 5. And then team A again, it will create an object, and team A will add team B. So team A has added team B. So obviously, team A in its hierarchy will come team B, and after team B, we will have this student one, and then team A will have student two as an independent member. So team A will have this student two, and then team A will have a member known as student C. So the team A will also have member student C. Now this student C will have again as it is a sub member, and these students are the sub member of team A. So team C will have team student S3, S4, and S5. Now let's say how this recursive algorithm will work. So here we have these functions, and by these functions we will see that how a recursion is working here. So we have this student class, we have this interface, and the third thing we have this team class. Okay, so now in this team class, what we did, we called the method m dot show details. So the m dot show details is a part of this is a part of our component. Here we have this component, so it is the part of this component. So m dot show details will call this component, and this component's show details will be revoked here. Okay, now as it was team A dot show details, so that interface will call this function of show details of team, and it will print its constituents, which is team A has team B. And then after it will print team B, then because of the recursion, it will again go to the student class, and because it is a student S1, so it will print the details of student. After the student details are fetched, then it will go to the second it will go to the second student, as it is again it is again a for loop. That's why student S2 details will be shown, and after that it will go to the team C. So team C call will again go to this team class, and after when this team class will be called, after that it will again implement this recursive call, and because of which student class will be called, and then student class will fetch the names of students that are S3, S4, and S5, which are included in this hierarchy. So like this, we will maintain an hierarchical file structure of a student, which is not possible without maintaining this composite pattern.